Alright, we are on lesson 14. Our objective for today says I will be able to calculate the theoretical probability. The theoretical probability of events using sample spaces and chance. So the probability. Probability is helpful when you're doing things like trying to figure out who is going to win a football game. If one team is 10-0 and the other team is 0-10, there's not an equal chance that both of those teams are going to win. It is more likely, or it is more probable, that the 10-0 team is going to win. So before we can get into all that, though, just a couple of quick terms that we want to talk about. First is sample space. Sample space is just the set of all possible outcomes for an event. So, for example, if you toss a coin, there are two possible outcomes, either heads or tails. Now, a simple event is an event only having one outcome. So, for example, rolling a 5 on a number cube is a simple event because that is the number that you rolled. That is the outcome. The theoretical probability of an outcome is found by by analyzing a situation in which all outcomes are equally likely and then finding the ratio. So, for example, the probability of landing on heads if you toss a coin is 50% or 1/2 because there's one heads and there's one tails. So, first thing we're going to do, it says a number cube labeled 1 through 6 is rolled. List the outcomes for each event. A number less than or equal to 3. So we want to list a sample space or the outcomes. So I'm going to put this inside brackets. I'm going to list all the numbers that are less than or equal to 3 on a number cube. Well, 3 is equal to 3, and then 2, and then 1. Okay? That is all of the outcomes. An odd number. I want to list all of the odd numbers on a number cube. This is just 1, 3, and 5. Okay? Those brackets. That's an ugly bracket. Let's see if I can make that better. That's a bad looking bracket. How about that? Something kind of like that. A number greater than 4. Okay, again, we're putting this inside brackets and we're just listing the possible outcomes. Only two numbers on a number cube that are greater than 4. That would be 5 and 6. It tells you that the number cube is labeled 1 through 6. Only numbers greater than 4 are 5 and 6. Now, to calculate the theoretical probability of an event, what you do is you've got the total probability of this event is the number of favorable outcomes over the number of total outcomes. So favorable is the number of outcomes that will come up based on the situation. Now, the complement of an event is the set of all the outcomes of an experiment that are not in a given event. So, for example, if heads is the desired event when tossing a coin, tails is the complement. So the favorable outcomes, if you're talking about the percentage chance that you flip heads, would be the number of times that you actually land on the heads, and then the complement would be the number of times that you land on tails. So what you know is that the sum of an event and its complement are 1. So 50% chance you land on heads, 50% chance you land on tails, you put those together, you get 100% or 1. Now, here we go. Calculating theoretical probability. There are 4 green, 3 blue, and 3 red marbles in a bag. Give each answer as a decimal and as a percent. So what's the probability of randomly choosing a red marble? Okay, well, we know that there are 3 red marbles. So it's going to be 3, that's the number of favorable outcomes over the total number of outcomes. Well, to find the total, I got to find the total of all these. How do I find the total? I just add. 3 plus 3 is 6. 6 plus 4 is 10. So 3 out of 10. It says to give it as a decimal and as a percent. 3/10 as a decimal is 0 and 3/10. To change that to a percent, you just multiply it by 100, which is 30%. So 3/10 and 30%. So it's the number of favorable outcomes compared to the number of total outcomes. On the back, what is the probability? Same thing, we still got 4 green, 3 blue, and 3 red. What's the probability of randomly choosing a marble that is not green? Okay, well, there are 2 different ways of figuring this out. What we know is that an event and its complement add up to 1. So we could do the probability of green plus the probability of not green equals 1. Okay? So what we could do is we could find the probability of green and then we could subtract that from 1. So let's do that. this is basically like an equation. What you see is, if I wanted to solve for not green, that's what we want to find, is the probability of not green. I could make this into an equation. I've got to get this by itself, so I could subtract this, probability of green, from each side. Those would cancel, and now I've got that the probability of rolling a not green marble is 1 minus the probability of rolling a green marble. So, let's go probability of not green, we're just going to call that NG, is 1 minus, well, the probability of a green marble, there are 4 green, out of a total we already figured out of 10, so that would be probability of not green. 1 if I've got a whole number and I'm subtracting a fraction from a whole number. Let's turn that whole number into 10 tenths. So 10 tenths minus 4 tenths. Running out of space here, so let's put it right to the side. Probability of not green is equal to 10 minus 4 gives me 6 tenths. It said to give that answer as a decimal and as a percent. So as a decimal, probability of a not green marble would be 0 and 6 tenths. Or, again, you could multiply that by 100 and you would get 60%. So that's one way of doing it. Another way of doing it is just figuring out the number that are not green. The ones that are not green are blue and red, so you could just say, well, there are 3 blue, 3 red, so there are 6 out of a total of 10, which is equal to 6 tenths, which is equal to 60%. So that's actually probably a little bit easier way of doing it. The reason I wanted to show you this is because I want you to see that if you take 1 and subtract the complement of an event, then you're going to also get the answer. Okay, so an event and its complement add up to 1. Alright, last problem. In a bucket there are 10 balls numbered as follows. 1, 1, 2, 3, 4, 4, 4, 5, 6, and 6. A single ball is randomly chosen from the bucket. What is the probability of drawing a ball with a number greater than 4? Is there a greater chance of drawing a number greater than 4 or a 1? Okay, well, first thing, what is the probability of drawing a ball with a number greater than 4? I got to figure out how many numbers are greater than 4. Well, 5, 6, and 6. So the probability of picking a number greater than 4, we figured out there are 1, 2, 3 numbers greater than 4. Out of a total, now I want to figure out the total number of outcomes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the probability of picking a number greater than 4 is 3 tenths. That's the first part. Okay? This says, is there a greater chance of drawing a number greater than 4? Well, we already figured out that's 3 tenths. Or a 1. Well, how many 1s are there? 1, 2. So, probability of picking a 1, there are 2 1s out of, we already figured out that there was a total of 10. So, is there a greater chance of drawing a number greater than 4 or a 1? Well, you've got a 30% chance here. You've got a 20% chance here, so there is a greater probability of choosing a number greater than 4. Because you've got a 3 out of 10 chance, which again would be 3 tenths or 30% of choosing a number greater than 4, and then you've got a 2 out of 10 chance would be 2 tenths or 20%. So 30% is larger than 20%. There's a greater probability of choosing a number greater than 4. That is all.